I like these because it's kind of like a puzzle to figure out what you should let u be and what you should let dv be. Okay. We have got x e to the x divided by x plus 1 squared. So we've got to find one thing that we want to take the derivative of and one thing that we want to take the integral of. And another thing that I could do, if I don't want to think of this as a fraction, is write this as x e to the x and then times x plus 1 to the negative 2. And I will tell you that we want to break it up into the x e to the x and the x plus 1 to the negative 2. So which one would you rather integrate? Okay, so let's let u be x e to the x and dv be x plus 1 to the negative 2 dx. Okay, so to find u, what am I going to have to do? Product rule. The derivative of the first times the second plus the first times the derivative of the second. How am I going to integrate x plus 1 to the negative 2? Negative x plus 1 to the negative 1. Good. Okay, if you can't do that in your head, do a u substitution and let x plus 1 be your u. And therefore du is just dx, so you don't have to do any substitution or any compensation there. And then you're just integrating u to the negative 2, which is negative u to the negative 1. So that's how we got that. Okay, uv. Nasty. Negative x times x plus 1 to the negative 1 times e to the x minus the integral of v du. Now, we don't have to do another round of integration by parts. So that means that to integrate that nasty something, somehow that integral has got to simplify. Tell me how. But I like the idea of factoring out an e to the x. Okay, so if I factor out an e to the x right here, I get 1 plus x. And which is to the 1 power. And so it completely cancels out. X plus 1 to the negative 1 times 1 plus x to the 1 cancels, and I'm just left with the integral of negative e to the x, right? And I can even pull that negative out in front and make it plus the integral of e to the x. So something that looks really, really scary can very, very quickly turn into something that's not very scary. Okay, number 5 fits every rule in the book. So those of you that were just saying, I thought when you said you had an extra power, you're going to let that be u. We're going to do that. So u is going to equal x squared. So therefore, dv is sine x dx. And the reason that this fits every rule in the book is that sine x is easy to integrate. We know how to integrate sine x. Okay, so what's the next step? Okay, du is 2x dx. No, we're just taking the derivative, not integrating, so we don't need a 1/2. And v is going to equal negative cosine x. All right, uv minus super voodoo. Negative x squared cosine x minus v du is negative cosine x times 2x. So negative 2x cosine x dx. Okay, to simplify this integral, right now I think I'm going to pull out the negative 2. So plus 2 integral of x cosine x. How are you going to integrate x cosine x? We're going to have to do u and dv again. Okay, but I promise it'll work this time. Good job, Hannah. All right. No, I will never make you do it 5 times. I promise. All right, now, the only rule about this is you've got to keep them in the same family. Like if you let u be the x squared the first time around, you need to let u be the x this time around. dv is cosine x dx. Okay, so du is dx, and v is sine x. Okay, so this x cosine x is a whole new uv minus super voodoo, but it's multiplied times 2, so I need to put some parentheses there. So uv is x sine x minus v du is sine x dx. I am going to distribute this 2 and integrate at the same time, if that's okay. So 2x sine x. And then what's the integral of sine? Negative cosine. So I'm actually going to get plus 2 cosine x plus c.